Okay. I think that don't see any other questions. So to sum up, okay, I think the remarks that you did about the difficulties that some of the projects have faced is because there was no one harmonized way, and the remark about this unique entity which could do this job, those are important. Of course, I keep the remark about the researchers from third countries to see what we can do on those two aspects. Thank you very much once again for this presentation. And then we move to Jean-Yves Blanc, who will focus more on infrastructure and research reactors. So Jean-Yves Blanc has a civil engineering degree from École des Mines. He spent more than 35 years in SEA, working on PWR fuel studies, fuel manufacturing, post-irradiation examinations, and also as project manager for hot laboratory facilities and also for waste facilities. And his present position is at the Nuclear Energy Division of SEA, and for international collaboration with Russia and also with Asian countries like China, India, and South Korea. Please, the floor is yours.
So thank you very much, Mr. Chairman. Good morning to all of you, or good afternoon. First of all, I have to apologize for this full title, which is very long, very complicated. And you should only spot two things. First, I will speak about the GHR, which is the Jules Horowitz reactor, which is under construction in Cadarache, in the south of France. And the other important point is the international cooperation, which is the core of our discussion this morning. And also, I should mention the main author, which is Gilles Bignan, which is in charge of the international aspects of the Jules Horowitz reactor project. So the contents are, thank you very much. So the contents are divided into two parts. First, I will describe the Jules Horowitz reactor for those which are not familiar with it, and what it is used for, and how we prepare the experimental programs to come. And the second part is devoted to all the initiatives we are organizing around this reactor and other facilities, and especially, of course, the European support which has been given by the European Commission to GHR. But I will also mention other initiatives through the IAEA, the OECD, and so on. As an introduction, I will make some comments about the panorama of the research reactor in the world, which has been evolving in the last years. First comment is that many research reactors, when I say research reactor in these aspects, I am mentioning big ones, are old, because they are mainly built in the 60s. For instance, in Dimitrovgrad, you have the CSM-3 in Russia, which started in 61. HFR in Pétain, same year. BR2 in Belgium, the year afterwards. ATR in US, which has been refurbished, but also started in 67. And the Mir M1 reactor in Russia, also the same year. So basically, you have lots of big, old reactors in the world. And as as a consequence, some have been recently shut down. In France, in CA, we have shut down Osiris at the end of 2015. The Japan material testing reactor was shut down 2 years ago. And the last but not least, the Halden reactor was shut down last year. And on the other side, we have only a very few which are under construction. The Jordan research reactor, which is a bit smaller, started 3 years ago. The GHR in France is under construction. The MBR in Russia is under construction with some problems with finance, as always. And recently, the US have also decided to build the versatile test reactor. And also, if you look at this panorama, you should take also into account that there is a lot of newcomers country, for instance, from Africa, which are looking either for research reactor or either a zero power reactor. I just mentioned 3 of them. Saudi Arabia has made a contract with IMVAP in Argentina for a small one, very small one. The Ministry of Education of Senegal is also looking for critical mock-up. Tunisia as well. And so, obviously, there is room for international collaborations and more coordination between all these things. So the Jules Horowitz reactor was designed with basically the same goal as the Osiris reactor, which was shut down some years earlier, but with a higher flux. And basically, there are 2 big objectives. The first one is to make some R&D for the nuclear industry, either for stainless steel, when we look at the aging of the plants. And the second one is for fuel behavior, either in incidental or accidental conditions. And the second objective is also to produce some radioisotopes, mainly molybdenum-99, and GHR will supply about 1/4 of the European demand, and with possibility to extend that depending on other reactors available at the same time. And of course, which makes the links with the previous presentation, it's also key tools for preparing the new generation and for education and training. So how it looks like? It's basically a research reactor with 2 nominal powers, either 70 megawatt thermal reactor, thermal power, or either 100 megawatts with a plate, circular plate type fuel elements. For the moment, it's uranium disilicide. It's a core about 60 centimeter high, and it's slightly pressurized. And it's inside, it's a pool type reactor. It means that the vessel is inside a pool. And I don't know if I can see. Doesn't work very well. There is a canal, and then from the core, you can go to some pools where there are some benches for non-destructive examination. And we have also 7 hot cells, 4 big ones and 3 small ones, for making, for preparation or dismantling of test devices, and also for radioisotopes. Of course, when you build such a reactor, the important thing is the test devices. So the test devices are related either to material or either to fuel. If I started with fuel, we will have some test devices for looking at the fuel under nominal condition. We will have some other ones making RAM testing. RAM testing was something which was very common either in Osiris, either in R2 in Sweden, or either in Halden. And also we will have a special device, the design of which was done by our Israeli partners, which is for making tests under LUCA conditions. A second type of devices is for material, either for stainless steel, to make some cooking of pressure vessel steel, either for some zircaloy materials, and also there is one loop which is foreseen for corrosion, and which is currently under design by our colleagues from Mumbai at the BARC. And there will be a prototype in Mumbai very soon. So the construction is in progress. So as you can see on these pictures, the civil engineering is quite finished. Most of the components are prepared in the factories, but not mounted yet. Also, we had some trouble with one of the contractors for ventilation and electricity, and now it's going on, which is importance of the picture in the middle. So the second part of my talk is to insist upon the fact that this reactor was designed from the start as a reactor for international cooperation. And the first thing is to mention that this reactor is inside a consortium where you have all this company. Of course, you will find the major French company like EDF, Technicatom, Framatome, there is still Areva, and of course CEA, but you have also the European Union, you have also Spain, Israel, CN, SCK in Belgium, Studsvik, VTT in Finland, the NNL in UK, and BARC in India, and also Czech people. And in some cases, like for instance CIMAT, the entity which is representing the country is also a consortium by itself. So when you are closing to the start of the reactor, you have to prepare the experimental program. And for that, we have started to make several actions to gather a scientific community around this reactor. So first of all, of course, there is a consortium, and this consortium has established 3 working groups, one for fuel air radiation, one for material radiation, and one for the technological issues. Second point, there is each year, normally in April, a yearly technical and scientific seminar. I think it's a picture you can see here. And also in this year, we have added to this seminar a GHR school. The second point, we have also the secondment of foreign engineers. Some are not coming from countries which are belonging to the consortium. For instance, we had somebody from South Africa during 1.5 years. And I will describe some other actions for this later. And of course, it's not everything. So this is the main topic for today. It's that for this project, the European Commission has been very supportive. So if you look at the different contracts which have been passed in the last year, at the moment, the European Commission has secured more than 5% on the access right to the radiation capacity, which makes the European Commission by far the larger foreign contributor to this research reactor. And there are 3 new actions which have been decided recently. First, the Euratom will increase its access right up to 6%. And also, if the funding is confirmed, there will be an interest of the Joint Research Center to develop an experimental test loop for the future requirement for the GHR. And finally, there will be a coordinated support actions to build a roadmap for the use of this access right. So basically, CA is very thankful to this continuing support from the European Commission. Another important topic is the ICER initiative, which was launched by the IAEA. If I remember correctly, it was during the General Conference of 2014. The idea of the IAEA is that on one side you have lots of newcomers countries from Africa, from Southeast Asia. We are contemplated the idea of having a research reactor, and the other side you have a research reactor which are available now, and some of them have even some difficulties to run all the year long. So the idea was to make some contacts, some networks between what they call affiliates, that will be entities from these countries, and entities of countries which have already a research reactor. Or in some cases, it's also countries which have a small research reactor. And so it makes a lot of networking. So CA was very interested from the start by this initiative because it makes a kind of second circle around the member of the consortium. And CA with GHR and some ancillary facilities like the hot labs was labeled in September 2015 at the General Conference. And now there are 4 ISER in the world. There are also the Belgian from CNSCK. There are the people from Russia, from Dimitrovgrad. And there are also the American labs. For the moment, we have 7 affiliates agreements which have been signed by CA with Slovenia, with Morocco, with Tunisia, with Indonesia, with Algeria, Jordan, and the last one with the United Arab Emirates. And the implementation of these of these agreements are in progress. It can be either secondment, it can be safety expertise, benchmark on core computation, and so on. It can be also people from CA going to the countries of the affiliates. A second initiative, which is also very important, is that, as mentioned at the beginning, the Halden reactor was shut down last year. It was shut down quite early, as it was expected to be shut down later. And so the OECD, which was in charge of the Halden project, tried to put a new initiative to keep some networking between the infrastructure and the customers. And there is a joint project proposal called the P2M that will involve the CNSCK, CA, EDF, and so on, with tests in BR2 and PIE, what will be performed both in Belgium and in Cadarache. There is another place also to discuss, to network between the people of the research reactor. It's the IGOR. IGOR is the International Group on Research Reactor. It's a forum for exchanges of information. It's a conference, basically. I think it's the 18th IGOR conference was held in Jordan last March. And the next one will be held in Dimitrovgrad in September of next year. It's about every year and a half. So it's, for instance, if you want more detail on some of the devices that will be proposed for the GHR, you can find it in some presentation in IGOR conference. So my conclusion is that the research reactor are key tools both for research and development, but also for education and training, and especially for hands-on training. So also if you look at the fleet of research reactor, about 80% of the fleets is composed of small research reactor, which are mainly used for education and training. But if you look to the future, if you look at more powerful research reactor, you will see that the future will be limited to a few new facilities which will be open to international program like GHR. Maybe something which is not written in the slide is that you have over research reactor in the world, but some of them are not open to international program. For instance, the Chinese are building a new IHEFTR in the south of Chengdu, but obviously there will be no international program in it. Also, if you want to make some programs in India, you have some troubles because this country has not signed the TNP. So some are not open. Also, as GHR construction is progressing, it is very important to start with the best test devices and the one which are most adapted to the customer's needs. And this is very important things. If you look at the member of the consortium, for us it's very important that the member of the consortiums ask or provide the devices which are the one they need. So, as I mentioned already, CA designed the GHR from the start as an international user facility, in which you have most of the many European countries, plus India and Israel. And we want to thank the continuing support of the European Commission through FP7 and H2020. And through this support, the GHR will offer access to European countries, and especially for research training. And also the international initiatives are well adapted to this collaboration, like the FISA initiative, the OECD initiative, the IGOR forum. So I think I have keep up in time, so you can have lunch at the good time. Thank you very much.